Hello and welcome to episode 4 of Super Simple Scala. Today we will be trying out a specification. The first part is object-oriented. The second part is more functional. We will read the specification, interpret the nouns and verbs, and make it into code. A company laptop makes 3 lines of laptop: the A4, the B16, and the C64. The A4 is available with 2 different kinds of keyboard layouts, the default being QWERTY. In addition, they use the same keyboard model in multiple different lines of laptops. So we have a reusable component here. Each laptop comes with a monitor, and internally each monitor is backlit. Things that are backlit generate a backlight, and they consume power. Lights come in strong, medium, and weak varieties. And in addition, for people with night blindness, there is a light enhancer that can be used to enhance the luminosity of a light. The B16 Super has everything that the B16 has, plus the ability to run a virtual machine. Alright, super simple specifications. Let's interpret that into code. So part 1, we have a laptop. And laptop has to be abstract because we can't just make any laptop. We have to make a specific model. So let's call this abstract class laptop. And all laptops have a keyboard. And of course, keyboard is an abstract concept, right? It's not a concrete keyboard. So let's say we also have abstract class keyboard. Okay. And keyboard has 2 different kinds, QWERTY and Jorvac. Class QWERTY keyboard extends keyboard. And class Dvorak keyboard also extends keyboard. We can leave these empty for now. They don't have anything really important in them. We could even maybe make them case classes. But this is going to have a keyboard. Keyboard, and by default it is going to be a a QWERTY keyboard. A second. So a keyboard of type keyboard, and by default it's going to be a QWERTY keyboard, new QWERTY keyboard. We usually should use a factory, but whatever. Alright, so we have laptop. Also, all laptops have keyboards. And then we have our 3 different kinds of laptop. I mean, everyone, this is just classic OP, right? So class, let's call this A4 laptop. Extends laptop. Class B16 laptop. Extends laptop. And class C64 laptop. Extends laptop. They all get the QWERTY keyboard. one of these guys to make it interesting, let's say that we want the user to be able to choose a keyboard, I guess, for the A4. So we would say val user keyboard of type keyboard equals QWERTY keyboard, and let's pass in user keyboard. So here it still defaults to QWERTY. QWERTY still gets passed in here, but these two guys save a little bit of boilerplate. Alright, so that's that. Each laptop comes with a monitor, and internally each monitor is backlit. Alright, so let's create backlights, consume monitor. Alright, let's create a, move it down here, a trait called backlighting. And let's have another couple of traits. Let's call these strong backlighting and I don't care about moderately. Too much boilerplate. Strong backlighting and weak backlighting. So there's backlighting. All backlights have the ability, so this extends backlighting, this extends backlighting. All backlights have the ability to generate light. Def generate light. Let's say it returns an int, and let's say the thing that it returns is the luminosity of the resulting light. So there's generate light, and there's def consume power, type int, return the amount of power consumed. Okay. What is the best way to go about this? All right, let's go. Let's say this is going to be 10 and 10. Let's define some constants in here. Val high power constant equals 10. Val low power constant equals 5. Let's go with backlighting dot high power constant, which I cannot access from this scope. High power constant, high power const, high power const, and let's call this low power const, low power const. Pretty boring. Now, we want to, for the people with night blindness, we want to be able to enhance it with a light enhancer that can double the luminosity. How will we double the luminosity? Well, what if this takes in an I int where at param, let's call this initial luminosity. Initial luminosity is the amount of luminosity initially. Starts out at 0. And let's call this initial. Let's just call these initial, just to make things easy. And what we're going to do is we're going to stack the traits. So initial, 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 initial. So there's that. And then we are going to have a light enhancer. Let's call this trait light enhancer. And light enhancer is also going to have these methods. Let's say, but it's going to do them a little bit differently. What it's going to do is it's going to take in initial, add 1 to it, and then initial, and add 1 to it. Now we're going to combine light enhancer with backlighting one of our laptops. So for example, if this laptop, there's another example somewhere down here. For example, like ball properties, this returns a string. Super.ball, that returns an empty list. So it doesn't actually need, I don't even actually need to provide the initial. All what I need to do is to say super dot. So for example, here we have red extends ball and shiny extends ball, and they both enhance ball. Well, let's say that we had light enhancer. And let's say that it just returns 1. What I'm going to do is these guys are going to stack together. And now this extends backlighting, this extends backlighting. And let's say that the light enhancer also extends the kind of backlighting. Now what we can do is override, 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 override. This is consume power. And what we're going to do is we're going to say super dot generate light plus, there we go, super, this is generate power, consume power. let's not worry too much about power. Let's just do light, just to cut down on the amount of boilerplate. Super dot generate light, and we can get rid of generate power. Okay, now that we've got all of that down, what we can do is we can say something like down here with the ball example, what we can do is something like new laptop with something with enhancer. So for example, val my laptop equals new A4 laptop with strong backlight with light enhancer, and where the super class here is just going to return 0. Initially we have 0 light, and then the way that the problem said is that light enhancer can be used to double the luminosity. So the light enhancer isn't going to add 1, it's going to multiply by 2. And for fun, let's say that I want my laptop, my A4, to be customized with that kind of keyboard. So let's give it the kind of keyboard that we want, new whatever keyboard, and then if we do println my laptop dot generate light, how bright is my screen, plus my laptop dot generate light, and we run this. Oops, let's ignore that and keep going. Console. How bright is my screen? 20. How did that happen? Well, if we go to C4, blah, 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 blah. So let's look at what happened. We had a strong backlight, which means that we started with super.generate light, which is 0, plus high power const, which is 10. So we initially got 10 because of the with strong backlight, and then we had with enhancer, where the light enhancer calls generate light next, and it does super.generate light. This returns the original 10 because we're going from left to right. So on the left side was the strong backlight, and then towards the right of that was the light enhancer. And then 10 times 2 gives you 20. And that's how we got how bright is my screen? 20. So again, let's take a second look at the specification just to make sure that everything lines up. We got the 3 different kinds of laptop. We got the 2 different kinds of keyboard. Same keyboard in multiple different laptops. Yeah, so the keyboard is a val, so you can reuse the same keyboard or like pass it around. If you wanted to, we could actually make the keyboards copyable. So because we want to be able to copy the keyboards, we could actually make this like that. And now, because of that, we can take the val keyboard equals my laptop dot keyboard, and then val keyboard 2 equals keyboard dot copy, and then we can use that same keyboard, my laptop 2 equals new A4 laptop, but we can use that same keyboard in another laptop. Keyboard copy. Keyboard 2 is of type implicit assert nothing. No, this is going to be of type keyboard. Don't worry about that now. Anyway, so we have our A4, we have our different kinds of keyboards. We have the backlight. We have they generate light. We have the strongly lit, we have the weakly lit. And in addition, for people with night blindness, the thing is, because every monitor has to have a backlight, what we can do is say what we can do to sort of prevent creating something without a backlight is we can do this of type backlighting. And what this of type backlighting does, I can actually put it in the superclass. Oops. What this of type backlighting does is it makes it so that if you try to define something without backlighting, without any backlighting, what it'll end up happening is illegal inheritance self-type A4 laptop does not conform to backlighting. So these are what provide sort of the lights. More specifically, there should be the light enhancer isn't really necessary, but the strong backlighting is, so there should probably be a superclass sort of that these two share, that the light enhancer doesn't share, just so that the light enhancer can be sort of excluded. If you make this of type backlighting, what ends up happening here, self-type A4 does not conform to backlighting, then this also has to be backlighting, backlighting, backlighting. So, oops, there's a mistake here. It says that that each laptop comes with a monitor that has backlighting. So monitor should be an external object. Strong lit and weakly lit, we took care of that. Light enhancer, we got that. We can mix and match if we ended up having different kinds of things that modify the light on the monitor. We can have with, light fixture 1, light fixture 2. We can customize that using the Scala traits. And virtual machine, super easy addition. Just super laptop extends B16 laptop, and then def run virtual machine ... All right, piece of cake. Next up, the harder part. Bye.